Okay, so now we're going to solve some absolute value equations. So what do we remember about absolute values? Just, right, what comes to mind? So remember the notation. They're the two parallel vertical lines. Right? And usually, right, there's a number or a letter in there. So if I have the absolute value of -5, right, it's an operation that we do on, right, the value on the inside. What comes out is 5, right? So everything that comes outside is positive, right? So it spits out positive numbers. You may remember that it is the distance from 0 on the number line. So if we think about the number -5, that is 5 spaces from 0. Now here's something you might not be aware of. Let me show you with that 5. So the absolute value of -5 is the same thing as the absolute value of +5, right? Now, it's also the case that the absolute value of a subtraction, so a minus b, is the same thing as the absolute value of b minus a. If you switch the order of a subtraction, it changes the sign, but if we're talking about absolute value, it stays the same. We might need that in a second. Let's see, anything else you guys can think of? Maybe you're thinking of the shape of the graph. We're not doing graphs right now, but yep, the shape it makes is the V. Good job. Okay, so let's go ahead and solve 4 of these. So the way we do it, and again, we're going to work on efficiencies. The way we solve absolute value equations is we're usually looking for that place, or we're going to set one side equal to a positive value and the other side equal to a negative value. And we're going to solve it twice. So we solve these equations twice. So the way I like to do it, and it kind of goes back and forth, right? The easiest way, especially if you just have one number on one side, is to let that number be the plus or minus, right? So this is going to be true if the 4x is 12 or if the 4x is -12. Now, if we're thinking about being true to the mathematics, then really it's the inside part that can be positive or negative, right, which we're going to do on these other ones. But if it's just equaling a number, it's easiest just to let that number change its signs. Okay, so if 4x is 12, divide both sides by 4, that'll tell us this is true if x is 3. Or if 4x is -12, again, divide by the 4. X is, now I have -12 divided by 4, that's -3. Okay, let me show you the other way because I'm going to be doing it on these other slightly bigger ones so you can kind of see. So if the inside is positive, right, it's just the 4x equals 12, right, there's that, I know, it looks the same, I understand, roll with me here. Or, right, that inside could have been the negative. So I could have had a negative, the opposite of 4x on the inside, right, equaling to 12, because, right, when I took the absolute value of this amount, it'd be positive, and we get there. So then I've got -4x equals 12, and there's that other, right now you divide by the -4, so the negative side was on the left side here, right, that still gives us 12 divided by -4, -3. Get the same answers either way, right, just one way is a little bit easier. Okay, let's look at B. So now I have the absolute value of 5x minus 2 equals 14. I have that single number here. So 5x minus 2 equals, okay, you ready for even more efficiencies? If you don't like it, go ahead and write out both, but you can do plus or minus 14 at this point. Okay. Now we're going to add 2 to both sides. Careful, the 2 doesn't combine with the 14 yet. It's going to be in front, so I'm going to have 2 plus or minus 14. And then we divide both sides by 5. So x equals 2 plus or minus 14 over 5. There are 2 numbers in here. Let me show you how you get them. So the first one is 2 plus 14 over 5. So 16/5. There's one answer. Or 2 minus 14. is negative 12, right, over 5. So here's the negative, right, going down that way, the minus line. Now, could you have done that, right, written out the two separate equations? Absolutely. Nothing wrong with it, right? Just kind of tidying up or condensing our steps for these linear equations. Okay, so on C, I don't have a side that's just a number. I can't kind of do that shortcut. So instead, I need to pick one side that I'm going to let be its positive and then let be its negative. You want to stay true to one side. Just pick one side you're going to switch, because otherwise, if you switch this side for one and this side the other, you're going to get the same answer out. Because, right, you've just sort of, well, you haven't let the one side be both options. Okay, so I'll go ahead and let my right side change its sign. So I'm going to just drop the absolute values from the left. Let them go. So 3 minus 2x equals, so here's the case when the right side was, right, the positive value on the inside. And then the case, so I'm going to keep my left side just as it is, so 3 minus 2x equals, and now I'm going to let this one be its opposite. So the way I do that is a negative sign out in front of parentheses. Sorry, getting a little tight in there. And then the 10 minus 6x, right? So I'm going to take the opposite of all of that, which means I'll distribute that negative sign. Okay, first let's hop over here to the nice one. So gather your x's together, add your 6x to both sides. So my numbers are going to be on the left, so move the 3, subtract 3 from both sides. So I have negative 2x plus 6x, that's my 4x. 10 minus 3 looks like a 7, divide by that 4, so x is 7/4. There's one of your answers. And then doing my, doing the other side, so 3 minus 2x, just keep that for a second. Negative distributes, so negative 10 plus 6x. Add 2x to both sides, add 10 to both sides. So those guys will cancel. 3 plus 10, there's a 13, equals 8x. Divide by 8, x equals 13/8. Okay, we should really check. Hold on, I'm going to graph these two sides and see that they match up. Okay, so I totally cheated and I grabbed Panopto and I grabbed both sides of this equation just to make sure that they intersected. As you can imagine, there are some absolute value equations that are not going to have solutions, but you don't really see that unless you plug them back into the equation and check. And frankly, I just wasn't willing to do it with those numbers. Sorry. Okay, D. So let's do our last one. Oh my gosh, look at that. I've got two absolute values, and I've got a coefficient, and I've got this extra term over there. Okay, this one I've already graphed. I do know it has solutions that work out, and they're integers, so life is really good on that one. But we're going to follow that same process. So this time we're going to pick our easier one. In this case, I think it's the right side, and let it be, right, the inside the absolute value. We'll take it for its positive version, where the absolute values just drop, and we'll take it for its opposite, negative version, where those absolute values turn into a set of parentheses with a negative sign. So left side, we're just going to drop the absolute values like they weren't ever there. So 4 plus x plus 13 equals, so then we'll do the one where they just, right, it's like we don't have them, so 2 times x minus 1. So I still have to distribute the 2 to everything. Tidying my left by combining like terms, I'll get x plus 17 equals, distribute, 2x minus 2. Subtract x from both sides, add 2 to both sides, gone, x equals 19. Okay. There's the answer when what's inside was positive. Now we'll do the other version. So I'll have 4 plus, again, just drop the absolute values, x plus 13 equals. So now I want that inside to be the opposite. So it's just like multiplying it by a negative 1, but that negative sign, like we did over here, it's going to go ahead and come out and live here by the 2. So it'll really be a negative 2, then that distributes, giving us that opposite version of the insides. So I still have that x plus 17, and then I'll get distributed -2, -2x plus 2, add 2x to both sides. Let's see, that'll give me 3x, and then subtract 17 from both sides, -15, and then finish by dividing by 3. -15 divided by 3 is -5. Okay, this one we could check both of those answers. I wouldn't mind doing that arithmetic just to make sure that right, we get the same thing on both sides.